Hello, let's continue our Sudoku adventure with Chilled by Matt Tressel. So we have normal 6x6 Sudoku rules, meaning in each row, each column, in each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also, in addition to that, have this diagonal on the grid that acts like a row, column, or box where we are placing the digits 1 to 6 exactly once each. Another way to put it is we do not repeat on this diagonal. And finally, we have this single slow thermo here. A slow thermo may not decrease as you move away from the bulb. So if this was, for example, a 3, this could be another 3, because 3 is equal. Equal is fine. Or we could be 4, 5, or 6. What we can't do is go down to a 2 or a 1, because that would be a decrease, and that's not allowed. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay. I guess we could pencil some 2s here. So there's no way this is a 2 at the end of this thermo. Why don't I start by penciling the thermo to show what I mean? So even if we started at 1 here, you can actually find the minimals in a similar way to the normal thermos, just by penciling the minimum digit and then seeing how that ends up at the end. So this we can repeat the 1. That's allowed. Here we can't repeat the 1 because Sudoku would prevent us. It's in the same box. So this would have to increase to 2. We can repeat the 2, increase to 3, and then 4. Repeat the 4, then go to 5 and repeat the 5. So we have 1 degree of freedom on this, meaning that each of these can be 1 higher because the 5 can this can actually be a 6. So 5, 6, 5, 6, 4, 5, 5, 4, 3, 3, 2, and then this normally could be 2, but the 2's looking at it. So that forces it to be a 1. And now what I was saying is these 2's looking in. This certainly isn't a 2, so that places a 2 here. That gives us this 1. 2 1's looking up, put a 1 in one of these 2. I was looking at these 2's here as well. Okay, so now 2 can't repeat on the diagonal. So this has to be a 2, which forces that 2 to be a 2 as well. Sorry, it forces this to be a 2, so it's not bigger than that. Can we finish 2's? Yeah, that's our final 2. All right. Now, anything else with 1's, maybe? 1's one of these 2. I am going to need a 1 on this diagonal. I guess it's in one of these. Okay. So how do we continue from here? Because these are minimals. This doesn't affect this guy. It's probably the diagonal. Let's see. So this is from 1, 5, 6. So the 3 and the 4 are here and here. I don't know if that's helpful. The 2's are done. The 1's. Is there anything else I can do with 1's? I don't think so. All right, so what is it? So maybe we can ask certain questions like, this isn't the right question, but where does this go in this box or something? What question can we ask here? See, I got all the 2's. The 1 can be up here, as far as I can tell. Okay, so actually there is one little trick we can do. I don't know how helpful it is, but since 1 is in one of these 2, this cell is never a 1, right? Look what happens if this is a 1. This can't be a 1 because of the column, and this can't be a 1 because of the diagonal. And so there'd be nowhere for 1 in this box. So the more direct way to say that, or so I guess the other way to say that, is that wherever this 1 ends up, it's going to eliminate this 1. So the 1 ends up in one of these 2. So if that's not a 1, and that's not a 1, that's not a 1. So that actually forces 1 in this column to be here. That's pretty interesting. So that's a 1. And now this is the only place for 1 on this diagonal. Because remember, it's down to these 3. So that's a 1, and that's a 1. Okay. And that places that 1. So needed to do some diagonal logic there. So now all the 1's are placed. What's next? Good question. I don't know much about 3 through 6 is the issue. These are limited. This is 5, 6 only. Are we worried about... Okay, there's one thing I can say, which is, I don't know if this is broken or not, but if these 2 were the same digit, So 5, 5 or 6, 6, whatever it is, we'll call it green. This is only if they're the same digit. They could be a pair. They could be like 5 and then 6. But if they're the same, then where does it go on this diagonal? It's in none of the cells I've highlighted because either, it's not in these because they directly see the green. Let's say this is a 1, which isn't 5, 6. So it would end up exactly right here and exactly right here. And then like this. So, I mean, it doesn't seem to break anything. But I wonder if that's the way we need to be thinking. What if they were different digits? What if it was 5, 5, 6? I mean, I guess I could write it out, but I don't really, I mean, this wouldn't be 5, 6. This would be 3, 4. I really don't see a problem with that. It would force this to be double 4. Are we saying that at least one of these is a double? Yeah, we're not doing 4, 5. Yeah, from 4, 5, 6, we're not doing 4 cells. So one of these is a double, either 5, 5 or, sorry, one of these is doubled. I don't know what, but let's say this was doubled then. Wouldn't go on the diagonal like this. So it would be here or here. I don't think that's nearly as helpful. What are we doing here? I can't really think of any other question to ask other than like, what if this was doubled and seeing if that breaks. Okay, well, actually, no, I do see something with this. If this was doubled, I don't know if it's broken, but I can see a step. It wouldn't go here or here. So one of these two would be green. I'm probably skipping ahead on something here, but if we look now at this box, this cell sees both of these. So this couldn't be green, and then this green looks in. So actually in the box, that would force this to be green, which means this would not be green. So this would be our green on the diagonal. If these two are the same, the green goes here. Which would mean the green goes here. And then now there's nowhere in this box for green. There's probably something much cleaner. I'm sure the comments will say. But these can't repeat because we'd end up being here and here. And then where does it go in this box? Because it can't be the two. This would look in. These two would look in. So we can't make these two repeat. So since they don't repeat, they have to be 4, 5 in this order. And that clears everything up. And remember, that did place the 6 up here. All right. So that's a 6, and that's a 4. This is a 3, 5 pair. This is also, not a 5. So that's 3, that's 5, that's 3. 4 finishes the box. That means that's not a 4. In fact, what's left in this diagonal? 1, 2. We need a 3 and a 5. This isn't 3, so that's 5 and that's 3. All right, diagonal's done. 3 in the corner. All right, these 3 digits are 4, 5, 6. This can only be 4. This can't be 5, so this is 6 and that's 5. Sure, this is a 5. That finishes the row with a 4. That places this 4 and this 5. This box finishes with 3, and then we need the 3 and the 6. All right. Cool puzzle, Matt. I don't know if that was the intended step, but I had fun with it at the very least. But yeah, we couldn't repeat these 2 digits. Very, very interesting, subtle interaction with the diagonal here and the placement of your givens. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.